Welcome back once again to the Enclosure Institute. Hopefully by now you know that I'm Phil Taylor.
And I'm Jimmy Budd. Don't worry, Phil, I don't think they could ever forget you. Today we'd want to spend some time looking forward to what we consider will be some of the demands on the future designs of enclosures.
During my lifetime, our world has evolved in many ways, but most noticeably in the role that electronics plays in our lives. Way back in our second video, Jimmy and I rattled off oodles of electrical devices that are commonplace today.
Oodles? Exactly how many are oodles, Phil?
Well, I don't know. It's a lot, maybe more than a few.
Okay, and those oodles of electrical devices are provided as sealed enclosures, but like Phil pointed out, the world of electronic devices has evolved with constant improvements and will continue to evolve. Some examples of rapidly evolving markets are data centers, battery energy storage systems, portable and personal medical devices, and of course, electric vehicles of all sorts.
Material suppliers like Rogers Corporation and converters like Marian have the technology, capabilities, and other resources to meet the challenges brought on by these emerging technologies. And although we don't have a crystal ball, we can foresee trends that will likely drive the next generation of enclosure solutions.
For example, devices and enclosures will continue to get smaller, thinner, and lighter in weight while becoming more capable and powerful at the same time.
And hey, Jimmy, check this out. This was my first mobile phone. It actually weighed about 20 pounds and hardly fit in the back pocket of my bell-bottom blue jeans. And check this one out. This was my first laptop computer, although they didn't even call it a laptop. The Radio Shack Model 100 had 24K of memory, that's all. And it really made me efficient because before that I made notes with a hammer and chisel on stone. So yeah, I guess electronic devices have gotten smaller and more powerful, and they'll continue to.
Yeah, Phil, thanks for the reminder. Not only will personal electronics become more streamlined, but in markets like automotive, aerospace, and mass transit, thinner metals and high-performance thermoplastics will be used to reduce overall weight to improve efficiency, conserve fuel, extend range, and prolong use between charges. But thinner walls mean lower enclosure forces. That makes softer gaskets and seals more critical than ever, which are solutions that are already being developed in the labs at Rogers today.
Thinner and less rigid enclosures also heighten the need for controlled venting. Venting, as we discussed in a previous blog and video, ensures the safe balance in the internal and external pressure of the device. An imbalance in this pressure can cause fatigue and failure to both the sensitive electronics and to the gasket sealing the enclosure. The data center environment is a good example. Servers run hot and cycle through large temperature shifts, making pressure equalization and moisture management crucial to the long-term reliability.
Similarly, battery energy storage systems and EV battery packs require venting solutions that allow gases to escape safely while keeping contaminants out. Medical devices too benefit from miniature venting systems that manage pressure without compromising sterility or functionality. As these markets and devices evolve, we also should expect safety standards to adapt and keep pace for flammability, heat resistance, and other performance criteria. This will be especially true in markets such as electric vehicles and other battery energy storage systems, where failures can be dangerous or even catastrophic.
You may recall in our conversations about the UL flame ratings of gasket materials that UL 94 is the standard for testing the flammability of plastic and rubber materials, including foam. That standard describes a horizontal burn test in which the test specimen is presented to a flame horizontally for a prescribed amount of time. After the flame is removed, the specimen is expected to flame out or self-extinguish within a short, defined period of time. This type of test is referred to as UL 94 HBF. Many, but certainly not all, foam gasket materials are tested to and will pass some form of the HBF standard.
UL 94 also provides for a vertical burn test, where the test specimen is presented vertically to the flame. This is referred to as UL 94 V0. The vertical burn test is much more difficult to pass than the horizontal test, and there are significantly fewer foam gasket materials available that meet the V0 standard. We expect more designs in electronic enclosures to require the V0 rating. Toward that end, Rogers is launching new materials like softer V0 Poron that balance safety with the compressibility needed for thinner structures.
The increased demand for safety and functionality is not limited to energy storage applications. As the Internet of Things expands, we expect that there will be more sensors, lenses, and receivers everywhere. Applications like door and home security systems, advanced monitoring in medical devices, and control sensors on driverless automobiles. All these will need reliable enclosures that protect sensitive electronics.
We see an increasing number of enclosures built for the outdoors. That certainly includes automotive, aerospace, and other transportation applications. But telecom equipment, for example, will continue to expand with exposure to the weather extremes around the globe and even into space. These devices will need to meet more stringent NEMA and IP ratings. We can anticipate advanced testing methods for stress relaxation characteristics to ensure reliable and long-term seals.
As we said, electronic devices are being asked to do more in smaller spaces, and higher operating temperatures are a byproduct of that. In data centers, for example, the increase in computer density generates higher heat loads, and a growing number of handheld medical devices require solutions that can handle rising thermal demands. The need for sealing materials to combine robust sealing performance with higher temperature resistance will be emphasized, not only for the devices to perform, but also to extend its life expectancy.
Beyond data centers, electric vehicles, energy storage systems, and medical devices, we're sure that tomorrow's applications will challenge enclosure designs in new ways. Lighter, thinner structures, tougher safety requirements, rising sensor use, harsher weather, and hotter environments are already shaping the next wave of innovation in sealing solutions. Our main goal with the Enclosure Institute is to give you the knowledge and tools to grow with the evolving world. And the good people at Rogers and Marian are not just watching these trends, we're preparing for them. So use us as resources. The solutions being developed today are designed with tomorrow's challenges in mind.
Well, that about wraps it up for us, Jimmy.
You're right, Phil. This concludes Module 4 and the base level enclosure content we've got to share with you. Congratulations from both of us to making it through all the content and Phil's jokes.
Ha! Both are worthy of congratulations, but you haven't heard the last from us yet. We're requesting a couple things from you. First is feedback. Check your email or the Enclosure Institute Hub for a survey link. Tell us what you thought of these blogs and videos. Please take a few minutes to give us your opinion, and don't be afraid to be critical. We want to know what you liked and didn't like, and what we can do to make this type of content more meaningful and useful for you.
Once you've completed that, we'll send you a certificate of completion of the Enclosure Institute for you to share on your LinkedIn or maybe even hang on your refrigerator. We'll also send along some handy tools that we hope you find useful.
And remember, all the content we've provided thus far is always available for you to review at your leisure and at your pace, and to share with others in your organization as you see fit.
And there will be more fun enclosure content to come. Subscribe to the Marian YouTube channel and make sure you're registered for the Enclosure Institute if you haven't done so already, so you can be the first to know when we've got new content to share.
And don't forget the useful tools and information we share with you on the Rogers and the Marian websites. We're always adding new resources to help you and your teams.
Yeah, we hope you'll be a frequent visitor and reach out with any questions, requests for solutions, samples, prototypes, quotes, or any other help that we can offer to make your enclosure reliable and the best in the business.
So signing off, I'm still Phil Taylor.
And I'm Jimmy Budd. So long for now.